Right, welcome everyone to the 2020 APAC Groundbreakers virtual tour by APAC OUC. This year event would be the biggest one ever done, with 174 sessions, including normal sessions, workshops, and hands-on labs. And this is from 123 different speakers over 11 days. Also, it would cover sessions in 4 different languages. Now, please remember to register for as many sessions as you can. All these sessions will be available for review or replay as many times you want for 2 weeks after the last session. You can also interact with the speaker at any time during the 2 weeks by posting questions or comments directly on the playback session page. Now, I would like to say thanks to the Oracle user groups and the Java user groups for making this event possible, and also to our sponsors, the Oracle Groundbreakers and CloudDB. Now, for today's session, comparing Oracle database performance in the cloud by Julian Dontcheff, please feel free to write questions at any time during the session in the Q&A tab of the Zoom webinar. You'll see that on the Zoom tab, there's an option to put questions. And what we will do is we'll get to those questions at the end. But if you do put some questions there, we'll try and get them answered. If we do run out of time, we will get to those questions afterwards. And now, without any more delays, I will hand it over to Julian. And what we'll do is we'll just quickly stop the screen sharing on my side, and it will switch over to his.
Good morning, everyone from Helsinki, Finland. Good afternoon to you. I think probably it's you're mostly from Australia, APAC. It's afternoon. I will be presenting for approximately 45 minutes on Oracle databases, and mostly on autonomous, performance, and cloud. And the presentation is based on several tests that we've done in the last couple of years. I would like to present you the results and probably show you a live demo from the Oracle Cloud. If you have any questions during the presentation, please feel free to interrupt me at any time, and I will probably try to answer the question. I prefer it that way. Of course, you can ask me questions at the end as well, but if there is something that is unclear, something that you would like to understand at once, please just go ahead and tell me, or put your question in the chat, and either someone will read it to me, and we'll try to answer it. Let me introduce myself first. I work for the Ankita Group in Accenture. I am Oracle Certified Master and Oracle Ace Director, and I run a database blog on the internet. You can very easily find it by Googling it. It's mostly DBA oriented. And I'll start with the first result that we did on autonomous database as soon as it appeared. With my team, we've been beta testers from the very beginning. We did also the beta testing of the dedicated autonomous. So the comparisons are different. There are comparisons between the Oracle database in Oracle Cloud, Oracle database in another public cloud, another major cloud database, and so on. Let's go step by step. And on the left side of my screen, you probably can see 2 screenshots. The top one, the gray one, is from the very first release of Oracle 2.3. That is the first one that was publicly released from Oracle Corporation, as there was never version 1.0. Actually, there was version 1.0, but it was never publicly released. I don't know some people who used it. But 2.3 was the first commercially sold relational database in the world. In 1979, in June, that's when it was released. And just for the record, Oracle is the first commercially sold relational database, but not the first relational database in the world. In 1977, there was a database called Multics. It didn't really prosper in any way whatsoever. The world was conquered by the Oracle database. On the bottom screen, you see the screenshot of version 4. That's when I started working with the Oracle database in around 87. And I've been involved now, even until now, with version 20. I've been testing version 20 on regular basis. So what did we do with the autonomous database? First, we decided to see, this is the first test, how it compares to the Oracle database in OCI. So first, there are a couple of numbers here, 14 performance acceleration and 1.6. So 14 is a multiplication of 8 times 1.6, and the number 8 came from our previous tests when we compared Oracle Cloud to another public cloud, major cloud, and we did come to the conclusion that approximately the performance for the Oracle database, not for the cloud itself, is 8-to-1 in favor of Oracle Cloud. When we put the autonomous database and compared it with our previous results, we found that it was 1.6 times faster. I will show you both tests that we did. And 14 is approximately 8 times 1.6. For those of you who've been inserting data and playing with data in a database, you probably understand that inserting approximately 500 million rows in approximately 3 minutes is not an easy thing to do. Here is what we did. So we did first database provisioning, and then we did the scale up, scale down hardware. If you think of manual install, of course, for manually installing the database, depends how you start the process. If you start moving the binaries from one place to another, it can even take more. But installing the database, creating the database, it might take up to 4 hours. Depends, of course, on the DBA. I've seen DBAs who can do it in 1-2 hours. I've seen DBAs who haven't been able to do it in 1 week. But let's say manually, it might take 4 hours, assuming that the hardware is already installed and you have the file systems. And the storage is attached. For database cloud service, it takes approximately 1 hour. And for ADW, for the data warehouse, for the autonomous data warehouse, it took us approximately 101 seconds. For the scale up and down, physical hardware, of course, technically that's not possible. Hardware is not elastic. Of course, you can, in some hardwares, you can add more memory and more CPU slots, chips, but let's assume that it's not an elastic thing. Database cloud service, scale up and down, it took about half an hour, but the database had to be down while the scaling is happening, so it's downtime. And for the data warehouse, for the autonomous data warehouse, it took us 1 minute, approximately a minute. Database was active while scaling was happening, so that was the first thing that we did. And then we decided to connect the database to an application, a real Accenture application called PRET, Platform Resource Enablement Tracking Tool, running on the Analytics Cloud Service. Data was replicated to Database Cloud Service and ADW. We wanted really to have a real life application usage experience. And we decided to have two different baselines, two different sprints. So the first one was with 3 months of data. And we compared how the performance of the database, of the autonomous database, was compared to the normal database of Oracle in Oracle Cloud Infrastructure. And we did the same for a much longer period of time, for 9 years of data. So we created 9 years of data based on the 3 months live data, which we had in the application. So we decided to really generate a high volume of data into the database. And we ran the same tests. We compared, we ran the same reports. And as a result, we saw that the average runtime for the first one was 1.63 times faster than Oracle database in OCI. While for the 9 years of data, it was almost the same, even faster, 1.72. So strange enough, it was even faster than with the 3 months of data. That was the first, not very much surprising result, but still it was encouraging results that ADW is really a fast database platform. What we decided to do next, we decided to perform, we wrote a white paper, by the way, about this. We decided to compare ADW with a major cloud data warehouse. So native cloud data warehouse, you probably guess from the color what database it was. We used in the next slide that I'll show you, we used a red for the major cloud database and blue for the Oracle database. We wrote a white paper on the results. This is publicly available. What we did is we took 3 different environments, one small, one medium, and one big one, big data warehouse with a lot of concurrent sessions. We ran reports simultaneously, and we had significantly more amount of data than in the previous 2 cases. What was probably as expected in the small and in the mid-size data warehouse, the behavior in both clouds, in the Oracle cloud and in the other cloud, the 2 different databases, it was probably the same. Oracle slightly better, but when we decided to move the volumes to a high-end data warehouse with concurrent sessions, with a lot of sessions and a lot of data, we noticed 2 things: that it was overperforming the other major data warehouse 2 to 3 times, and also we did the calculation for the cost of both cases, and Oracle had, of course, the upper hand. So here is a screenshot from the white paper that we did. The red one is the major cloud data warehouse, and Oracle is the blue one. And those are several reports that we tested, approximately 2 to 3 times faster for Oracle, exactly the same tables, same data warehousing cloud. And we used, for this comparison, we used really a data warehousing schema. The data was from a real data warehouse. This is from a real client case. This is a little bit more on the financial side. So how, when you move from Exadata, how it would affect you the case for 5 years, from Exadata to ADW. So the first year, we had 88% savings from the client, and from the second to the 5th year, 54%. You can see that the numbers are a lot. You don't have to go for them. It was everything: storage, labor, network, hardware support, operating system support, also the database options, and so on. Here's the same result, but in a more graphical view. So you can see that if you move from on-premises, Exadata on-premises to autonomous data warehouse, also running, of course, on Exadata, then you see that the savings predominantly come from I would say, everything, even from the labor. And from the second to the 5th year, of course, also you come with probably half of the cost that you would have on an on-premises database. So I'll continue probably a little bit later on with the PowerPoint presentation, but I would like to probably right now make a small demo for you with the autonomous database, not just show you PowerPoint slides. This is Oracle Cloud. I have 3 autonomous databases. I have created 3 ones, and that's what I'm using. One of them is JSON, one of them is TP, transaction processing, and one of them is a data warehouse. Those are my own, so I pay with my own money for that, so that's why they're mostly stopped. But I'll show you something with AEG, which is the new JSON database. Probably most of you, if you have logged into the Oracle Cloud and connected to autonomous databases, you probably know that the connection is you usually connect as admin user from any client tool like Oracle SQL Developer. I have here Oracle SQL Developer. Let me see if I can connect. I'll connect as admin. Admin is the high-end user with most privileges in the database. Let me first test if it works, because that's a live demo. Testing connection, yes, okay. Connect. This is a database I have in Frankfurt. Let's just run one simple query against the database. Once I connect it, we can confirm that everything worked before I start doing anything else. Let's check the database version, select start from $v version. All right, everything is fine. We are connected to the database. We're having 19.5. All right, any questions so far? All right, in that case, what can we do for the short period of time we have? One of the newest things that Oracle came with autonomous is autonomous data guard. And you can see here, autonomous data guard, it's a standby database instance in a different availability domain. So different availability domain, you understand it probably in a way that it's a different data center, like in Frankfurt now, where I am connected to. There are 3 different data centers. They're called ADs, availability domains. And I will try to create a data guard for you on that database. For now, I don't have one. And what happens if the primary instance becomes unavailable, then the autonomous database will automatically do the switchover. And then we will create another standby database behind my database. If there is no another availability domain in the same region, then Oracle will create the data guard, the autonomous data guard, on another Exadata machine, on another Exadata frame, a different isolated physical computer. All right, so it is very easy, and let's try to enable it. So you just click on enable, and enable autonomous data guard. That's all I'm being asked. So Oracle creates a standby database and incurs additional service cost. So you get a warning that this will double your cost, because you basically will have two databases. Do you want to enable autonomous data guard? And I say enable. So let's see how long time it will take. So now it is saying updating. Let us see, of course, at the moment I'm using the database. Of course, everything should be fine. If the database is up and running, select start from, let's say, DB users, anything, something, just to check that the database works. Fine, we're getting what we want. What is important to note here that this is not data guard like the way you're used to data guard. This is not the traditional data guard. This is based on refreshable clones, and Oracle uses log apply to create and recover the standby site. So just for your knowledge, this is not the normal data guard. This is not a real standby database. This is based on refreshable clones and redo apply. So we're waiting until Oracle is creating the autonomous database. Probably most of you who have created in their career a data guard, it doesn't take minutes. It takes, I would say, more than an hour at least. Of course, depends very much on the size of the database. For a small database, it can take less than an hour, less than 1 hour if you're enough experienced to do it. But in most cases, it takes time to first transfer the backup. Of course, you can create the database using network links starting Oracle 11, but it is not something that you do in 1 to 3 minutes. Let me refresh the page. See, sometimes you need to refresh to see really the current status. And once I have the database created as a standby database, then I'll try to do a manual switchover and we'll see how it works. Important point, once I have the standby database, we are not allowed to connect. We cannot connect to the standby site. There is no way. So it's just a backup database. You can think of a DR site, a DR database in another Exadata. And I have tried to find a way how to connect to that database, but it is impossible. I found it even documented. And Oracle is still provisioning. It usually takes, I would say, between 2 and 5 minutes at most. I can probably see if I can still connect to the database. Of course, I can connect if I can run another select stuff from, let's say, CDB. PDBs. Do I have access even to that one? Yes, I have one PDB. Actually, what I'm having here is a pluggable database. That's a pluggable database. What Oracle will create also in another container is another pluggable database. Let me refresh once more. All right, it's still updating. Okay, I'll go back to the presentation and we'll come after a while to check. We started at approximately 15, 16 past. Let's see how long time it will take. Let's go back here. All right, so this was about the total cost of ownership for the data warehouse. We did also another study. This is a paper that we published a few months ago this year, in the beginning of the year. It is a comparison between the cost of Exadata and autonomous, because you can get Exadata and autonomous now in several flavors. Forget the on-premises one, that's clear. But thinking of Exadata and autonomous from the cloud, you have the Exadata cloud service. And from the Exadata cloud service, you can get a quarter rack, you can get a full rack, you can get half a rack. You have also the autonomous database. You have the shared and the dedicated option. So at the moment, what you saw on the live demo, I was connected to the shared version of autonomous. And you have the dedicated one where you get the quarter rack. It's your own half a rack or full rack. And you, even for every autonomous, you have the free option, as I showed you. You have the JSON database, you have the transaction processing database, and you have the data warehouse database. So you have really a lot of variants. And if you want to see really what would make sense for you in terms of money, we did compare based on monthly cost. So this is monthly cost in dollars, so $10,000, $20,000 a month. And the first one is autonomous dedicated, shared, sorry, ADB shared with 4 CPUs and 1 terabyte storage. Then we compared it to shared also with 4 CPUs, 128 terabytes of storage, so much bigger database in size if you need more than 1 terabyte. And then we have the dedicated one quarter rack with 4 CPUs. We were testing on a quarter rack, and we have also the Exadata cloud service. You have the quarter rack, the half rack, and the full rack. And you probably don't have to read now all the numbers. You can very easily find the white paper on the internet. If you just Google probably for Accenture white paper, monthly cost, Exadata autonomous, you'll get the PDF file. It's not a big one, 5-6 pages. But in short, the conclusion is that if you, for example, have a company where you need to put your database on a mission critical system, you have business critical application, you would like to have a secure isolation, you need a HA platform, and you would like really to take use of all the features of Exadata performance, dedicated is the best option. So ADB dedicated. The shared one is probably the best case if you want to go to the cloud quickly. If you don't care about maintaining infrastructure, because with dedicated, you have a lot of things that you do on the infrastructure side. And shared does not require anything to do with the infrastructure. It doesn't have full isolation. So basically with shared, you might get a PDB in the container, and somebody from another competitive company can have a PDB, a pluggable database in the same CDB, in the same container. You don't know. You share resources basically with somebody. And if you think of database consolidation, probably the best is the Exadata Cloud Service. It can handle all mission critical routes, all business critical applications, especially if you'd like to have consolidation of several databases, and you would like, of course, to have the HA for the system. And of course, Exadata Cloud Service works with all packaged applications like EBS, Siebel, PeopleSoft, JD Edwards. And I've written here that they are not yet supported on the Autonomous Database platform, but this was written probably a couple of months ago. Now Oracle are supporting for Autonomous, they're supporting Siebel, they're supporting PeopleSoft and JD Edwards. Only EBS is not being supported yet. As I hear, it's still in the pipeline. It's the most complex, probably one to be supported for Autonomous. And let's go back to the cloud. Still updating. Okay, I had to refresh it probably. Now the database, the standby database is created. You see it's available. And let's try to do a switch over. I'll click on switch over. And here I need to type the name of the database. So do you want to switch over to the AG confirm? Yes, I confirm. And now I'm doing manual refresh. Sorry, manual switch over. Let's go now to SQL developer and let's try to run a query. So select start from V version. You see, I'm getting an IO error. Okay, select start from DB users. It's hanging. So it is a short period of downtime while Oracle is doing the switch over. I cannot connect anymore. Sorry, I'm connected, but I'm sort of disconnected. Like this is always what happens. In the very beginning, you just get a hanging session. And this is clear. This is well documented, and it's expected that during the switchover, there is a change in rows in progress. And after a while, I can open a session to the standby database. Actually, I connect exactly to the same database. Oracle is redirecting my connection. I'm not making any changes in my connection. So let's try. This is exactly the same, same admin user. I'm using the same zip file, wallet zip file. And if I click probably test here, I'll get either an IO error or I'll probably get some listener error. Let's see what I'll get while Oracle is doing the switchover. It might hang for a while, and then usually what I've noticed that it's either IO or listener, missing listener. And this also takes, I would say, around 5 minutes if everything goes fine. Let's wait for the final result from the testing connection. In the meanwhile, any questions or comments? Is there anything in the chat? Okay, success. Oh, it happened so quickly. So you see, I got success. So let's try to connect. Usually takes much longer. That surprised me a lot. So I have no explanation why sometimes it takes seconds, why sometimes it takes 5 to 10 minutes. Let's try. Select start from the instance. All right, so you see, I'm connected to the database 19.5. It's open, usable. The downtime was, as you could see, seconds. I would say less than a minute, half a minute. What probably you're wondering, why is it still saying updating? Oh no, it became available, you see. But sometimes the graphical interface in the browser is not in sync with what is really happening in the database. So usually you get the result here a little bit later than it happens in real life. So when you start the database, it will be probably saying starting, but at one point you're able to connect. Sometimes you have to refresh the browser. Sometimes it's refreshed automatically. You see now it happened automatically. What I can do now is I can disable data guard because I'm now paying twice for the same database. So that doubles my charges. That was just for the sake of the demo. It is very easy to disable it. By disabling it, Oracle will automatically remove the standby instance. So disable, I have to put the name and disable autonomous data guard. And updating. Let's see now if I'm able to connect. Select star from, I'm connected, of course. Select star from DBA users, something, just to see if I'm getting a response. Everything's fine, of course, because Oracle is basically dropping the standby database. Nothing is happening on that pluggable database. That's more than clear. At one point, this should become green. All right. Any questions as of now? Or do I move back?
Yes. Yes, Julian, there is one question.
Yes, please.
The question is, when you compare Exadata on-prem versus ADB performance, are you comparing like for like, or are you dropping all the indexes and using autonomous indexing?
We are comparing like to like. We did use autonomous indexing, meaning probably auto indexes. We are not using auto indexes. We did a separate testing on auto indexing, and that's a totally separate discussion and separate presentation that I'm having on auto indexes, on automatic indexing, but we are not using auto indexing. It was like to like. All right. See,
Thank you.
Yes, thank you. Yes. You see that now everything is back to normal. I'm having the standby, the single instance, the pluggable database, and I'm still in square one. If I want to enable data guard, I can enable it. And you see probably it didn't take us more. We started probably the whole demo at 15 past, 16 past. So it took us less than quarter an hour to enable data guard, to do a manual switch over and to disable it. All right. Let's go back to the presentation then. All right, so what did we do next? We took a leading cloud provider, and now probably you're guessing which one. I'm just not allowed to tell you the name, but you can guess. We decided to do a very similar database system on both clouds. We created the same on autonomous data warehouse. So we did use 16 virtual CPUs, which is equal to 8 Oracle CPUs. I'm not talking licenses here, I'm talking cores. And we did the same for autonomous, 8 CPUs. We had approximately the same memory. Of course, with autonomous, as you're probably aware, you cannot set up the memory parameters. You cannot set memory target or SGA target or PGA aggregate target. Oracle decides how much memory you have based on the CPUs, and they grow linearly. So if you have one CPU, if you create an instance with one Oracle CPU, you will have something like 10 gigabytes. If we have some time at the end, if you're interested, I can show you. We can connect to the autonomous data warehouse and see how much it is. Depends if it's ATP or ADW. In ADW, you get a little bit more of HGA target and you get more of HGA target than PGA aggregate target because of the aggregations. In the transaction processing system, it's the opposite. But let's say approximately 10 gigabytes for one CPU. So if you have 8 Oracle CPUs, you get approximately 80 gigabytes. So here it's around 80, 90 gigabytes. And this is the combination of PGA and SGA. And disk type, disk size, what we did? We noticed that let's do something even more aggressive. Let's create the autonomous data warehouse with 2 CPUs. And then it will have approximately 20 gigabytes of memory. Of course, also you have Exadata storage and 1 terabyte. So we decided to calculate the price of a query. Of course, first you look at how many queries you can run an hour. We did exactly the same table structure, same database. We ran the same workload, same SQLs. And in the leading cloud provider, we were able to run 65 queries an hour. In OCI, 1,200 plus, close to 12,000 in the 8 CPU ADW in autonomous, and 2,500 in the small configuration of ADW. Then we decided to calculate the cost of the systems. And we took into account, of course, that we are using Oracle Database Enterprise Edition with advanced security option. And the term commitment was 3 years. We calculated the annual infrastructure cost and, of course, the Oracle DBA support. And For the leading cloud provider, the price was a little bit more than 100. For OCI, a little bit more than 60K, 100K approximately for the larger autonomous data warehouse configuration, and 46 for the smaller configuration. And the more common way that you can calculate what you get for your money is to calculate the price of one query, the price of one report for your system. And what we did is that we decided to divide the annual cost with the queries an hour. So we calculated the cost per hour and the cost for one query. And as you can see from the table, that for the leading cloud provider, we got approximately 20 cents for one query, half a cent for OCI, 1/10 of a cent for the larger ADW autonomous implementation, and 2/10 of a cent for the smaller configuration, twice more expensive than the larger one. So you see the difference is even unheard of. So something like 99 to 100 to 1. What also happens is that we took into account the patching for security. So for the leading cloud provider, for OCI, when you're responsible for that, patching can take days, can take weeks, even months. While with ADW, it's real time, and you really get it online. I've been really curious what happens when you get from Oracle the emails that there will be downtime because of security patching or some type of patching during the weekend. And I've been following during that period of time the connections to the database. I have not seen any hiccups. So it's really online patching. I hope they patched it, of course, because you don't get any notification for that. But it really was without any downtime, and everything worked fine. So basically the conclusion, the statement I would like to make for you is that Oracle loads runs best on Oracle Cloud. And that was my last slide. I would like to also at the moment now probably take some questions if there are any. Let's see.
Yes, so just for everybody that's on the call, all the attendees, you've got, just to give you an idea, if you go to the Zoom menu option, you'll see there is a Q&A section. And what you can do is if you've got any further questions, you're welcome to add your questions there, and we can then answer them. So we'll give a couple of minutes if you've got any questions. If you're welcome to add it there.
I can probably also show you how to see the memory for one CPU. I told you that approximately 10 gigabytes. I don't remember by heart. We're still connected to the database. Well, let's check. Select star from the parameter. I have one CPU here and 1 terabyte. Parameter where name like. What do you want to see? Probably the SGA. Okay, so you see SGA max size is SGA target. SGA target is 8 gigabytes. You can see here, 8 gigabytes. And let's check also PGA or name like PGA. And this is the JSON database. It's very much like the transaction per setting database. So the SGA is 8 and the PGA aggregate limit is, PGA aggregate target is 3. So 8 plus 3, 11. I said 10, so it's approximately 11, 8 plus 3. You get very similar if we connect to the ADW or ATP. And you cannot influence on that one. If you, for example, decide to double the CPUs, you most likely get from 8 to 8 will be doubled and 3 will be doubled. Why don't we do it? Let's try to scale up. So let's increase the CPUs from 1 to 2. Update. You see scaling in progress. This is also a live operation, so no downtime. And let's try to rerun the query. So it's still 6 and still 3. I don't know how, it usually should take probably about a couple of minutes. And at one point it will change. So 6, 3. Okay, you see it increased it. It increased it to 32, and here it increased it to 16. And I'll tell you why, because I have auto scaling on. I shouldn't have had auto scaling on. When you have auto scaling on, Oracle increases the memory 3 times. And that means that basically when you have workloads which need more than the 2 CPUs that I'm now demanding, Oracle will be able to run the workload without any problem. The system won't starve, but then Oracle will triple the CPUs, and by that the memory as well. And in that case, you pay only for the period when you have the scaling, the auto scale. You see it's available now, it's clear, but I will scale down, and I will disable auto scaling. So I'll scale down to 1 CPU. Let's say 0, 1. And I disable auto scaling. That is the explanation. 32, 16. And now once I disable it and I reduced again to 1 gigabyte, to 1 CPU, I will probably have less than 16. It should probably change now back to 8, and this should change back to 3. And you see 3 megabytes times 2, it's 6. Here it doubled it, 8 times. It was 8, and then it increased it twice because I asked for 2 CPUs. So be very careful when you do it with auto scaling, and if you have the scaling option on, because then at some point Oracle, if you enable auto scaling automatically, Oracle can triple the resources. Of course, you will pay for that, but you will not have the performance issues if you need more resources on the system. So scaling in progress. Let's check once more if we're back to normal. Yes, we're back to normal. You see the PG aggregate target is now 6, and the aggregate target is 6, is 3, and the PG aggregate limit is 6, and the HJ target is 8. You see, although it says still scaling in progress, scaling has been done already. So that's a bit misleading statement, but probably I need to refresh it or just hit Rex a little bit later. I think that's it. That's the last demo. I don't have more. Any questions from anyone? I see there are no questions.
Yep.
In that, yes?
Yep. No, thank you so much. Do you have anything else you would like to add?
No, I think that's it from me. And thank you very much for taking part in this presentation and in the live demo. Have a nice evening. Goodbye.
Cool. Thank you so much. And thank you everybody for joining the session. That was really exciting and a lot of good information in there. Please feel free to register for more sessions, and you're welcome to stay in contact with the speakers through the speaker page. So you'll see that there's through the session details, you'll be able to connect there through to with the speakers as well. Hope you enjoy the rest of the conference and enjoy the rest of your day. Thank you so much.
Bye-bye.